Okay, so now that we know all about FOIL, let's take a look at another unique situation when it comes to multiplying binomials to binomials. And the name we're going to give it is the difference of squares. So that'll become clear as we do our work. Why do we call these situations difference of squares? And before we do anything, I want you to guys take a look at my 6 products, and hopefully you see a pattern. All right, so let me go ahead and let you guys look at those 6 products for a moment and see if you can identify a pattern. What seems to be the same thing in all 6 products. Okay, so the first thing I hope you guys notice is that we have a by times a by. All right, and then the second thing is one of the binomials will be an addition statement and the other will be a subtraction statement. So let's go look at that. Right, so there's an addition statement, subtraction statement. Flip-flop, but I have an addition statement, a subtraction statement. Addition, subtraction, subtraction, addition, flip-flop, addition, subtraction, addition, subtraction. So 2 binomials, one's addition, one's subtraction. And then the next thing is that notice that the terms are the same. So what are the 2 terms in this addition? X and 2. What are the terms in this subtraction? X and 2. Right? What are the terms in this subtraction? X and 5. The sum has X and 5. Right? My 2 terms here are 2x and 3 and 2x and 3 in the difference. My terms in the difference are 3x and 4, and then the sum has 3x and 4. Even these fractions, right? The 2 terms are 1/2x and 2/3, and we're still dealing with 1/2x and 2/3. A and B, A and B. So that creates a very unique situation. When you see that pattern, let's take a look at what happens. So I'm going to first approach this by knowing what we now know. Let's FOIL this, and then we're going to see hopefully a pattern, and then we'll just have a real neat shortcut. So if I go through this FOIL, first times first would give us x squared. When I do the outer, I get a negative 2x. When I do the inner, I get a positive 2x. And then when I do the last to the last, what I get is a negative 4. And then you'll notice, because we had same terms and different signs, take a look what happens to the 2 terms in the middle. The outer and the inner terms, they effectively cancel each other out. And all that's left is x squared minus 4. And so what we have is a difference. And then the reason why we call it a difference of squares is because clearly x is being squared on the front end, and this 4 is 2 squared. And where did I get the x and the 2? Well, those are the 2 terms that were involved in the binomials. So square the first term, square the second term, and then you have their difference. Difference of squares pattern. So if you're following along, if you see the pattern here, what I'm expecting is the first term squared minus the second term squared, or x squared minus 25. That's how fast this can be if you recognize the pattern. If you're not seeing the pattern with me, let's do good old reliable FOIL. So first times first is x squared. Outer would give us a positive 5x. The inner would give us a negative 5x. Last times last would give us a minus 25. And again, because they're same terms, different signs, the outer and the inner cancel out, leaving us exactly what I predicted. Right? First term squared minus second term squared, otherwise known as the difference of squares. Okay, so let's see that in the next one. Again, we have a sum and a difference, same terms. So what am I expecting? Well, first term squared minus second term squared. Cleaning that up using our quotient. When we have a power of a product, everybody gets hit, right? So 2 squared is 4, and we get x squared, and then 3 squared is 9. So that's what I'm expecting as my final answer by using my difference of squares pattern. Of course, just to check it out, let's FOIL it. Let's do it the old-fashioned way. First times first, well, 2x times 2x. There's my 4x squared. My outer would give us negative 6x. My inner would give us positive 6x. And then last times last gives us minus 9. And then again, because the terms are the same and different signs, the outer and the inner cancel out, leaving us exactly with what I said would happen using our pattern. All right, so difference of squares pattern. It basically it's like a formula essentially. It is a formula. And so I'm just going to use that here on out. So again, I have a difference and a sum, same terms. So the difference of squares, we're going to take the first term, we're going to square it, and we're going to subtract the second term, and we're going to square it. And so using my power of a product, I square each factor, and then 4 squared is 16. And there's our answer for number 4, using the difference of squares pattern. Of course, I invite you, if you're not sure, go ahead and FOIL it out and see for yourself that it works. And then number 5, pushing around fractions. Again, we saw in the last video that's doable, but it gets a little crazy. But I'm going to use my difference of squares pattern here because I see a plus and a minus in the same two terms. So I'm going to take the first term and square it, and I'm going to subtract the second term and square it, the difference of squares. And then we basically have our power of a product and quotient and a power of a quotient. So everybody gets raised to the first power. So 1 squared is 1, 2 squared is 4, and we have x squared. Minus 2 squared is 4, 3 squared is 9, and there's basically your answer without having to push too many fractions around. So 1/4 x squared minus 4/9. Jumping ahead a little bit so you can see the pattern, I got a couple of variables. We'll talk more. Hopefully you can follow along, but I want to establish a pattern. Again, a times a, this is and b times b. It's a sum and a difference, so we're going to take the first term, we're going to square it. We're going to take the second term and square it. And what you have is basically in formula form, a plus b and a minus b results in the world famous difference of squares pattern. All right, and so that's a formula that hopefully you guys can start to memorize because it's going to help us in chapter 5 and helps us with some products here. One last thing I want to mention, make sure that you see the product, or you see the pattern. Here's one more example. As a matter of fact, I'll put it in red so you can kind of see the difference. So let's just say I had 3x plus 5 and then 2x minus, let's say, 3. Okay, so these are two binomials. One's a sum and one's a difference, but this is not the difference of squares because the terms are different, right? The first term is a 3x and a 2x, and the last term is a 5 and a 3. So this pattern does not apply. So you don't panic, right? Just because you have a shortcut, if you can't use it, you can't use it. We just rely back on our FOIL, right? And so 3x times 2x, my first times my first is a 6x squared. My outer is a negative 9x. My inner is a positive 10x. And my last is a negative 15. And so because the terms weren't the same, right, you'll notice that the inner terms, the outer and the inner, are not canceling out like they did up here when we had the pattern. So be careful. Let me clean this up. When you want to use the pattern, you have to have the pattern. You have to be two binomials, one's a sum, the other's a difference, and then the terms are the same. If you got the pattern, you can use it. If you don't have the pattern, you can't. All right, so that's another special situation for binomials, the difference of squares. We'll take a look at another one in the next video.